In this video, I will show you how to test your application using the Synflow SDK. And I will also show you how to perform a synthesis of your application, of your IP core, using the Synflow SDK. So I have decided to use a UART network, a UART application, to show you how to make a synthesis and how to make a simulation. So what's a UART? A UART, it stands for Universal Asynchronous Receiver Transmitter. So it's not a communication protocol like SPI or I2C, but a physical circuit in a microcontroller or standalone IC. The main purpose of a UART is to transmit and receive serial data. So in UART communication, two UART communicate directly with each other. The transmitting UART converts power data from a controlling device like a CPU into serial form, transmits it into serial to the receiving UART, which then converts the serial back into parallel data for the receiving device, which can also be the CPU. Only two wires are needed to transmit data between two UARTs. Data flows from the TX pin of the transmitting UART to the RX pin of the receiving UART, like you can see in this picture. So the data are very often used to make two things communicate together. Usually it's for debug purpose. So we have a UART implemented in CX. You can find that in the example master repository that is in our GitLab repository. So feel free to check that on GitLab to download the code and to have a look on the CX code. The UART network is composed of 4 subnetworks. So we have 2 parts. One is for receiving data. So this is UART RX and buffer RX, and one is for sending the data. So the upper part is for receiving the data from another UART IC via the RX port. So data arrives on the RX port, are processed by the UART RX and are sent to the CPU via a buffer, which is in fact a FIFO. And we have the transmitter part, so data are sent by a CPU to the buffer TX. So the CPU is here connected to data to send. The buffer TX receives the data from the CPU, and the UART TX read those data and process those data and send the data to another UART IC via this TX port. So this is a UART. You can see all instances here, the 4 instances. Yeah. And as you can read, the wide is 8, so wide is 8, so this data to send here, it's 8 bits, and ARX is a single line, single bit. So it's a boolean in our case. So to test that, it's very easy. So you need a top network, the new network, and in this network you will instantiate the network you want to test. So here is the application of the IP core I want to test, your network, the one I just showed you. And connected to this network, I have a source, the dummy TX. So those two are acting like a CPU. They provide, they feed the UART network with data. And on the other side, I have an expected and a dummy test. So those two tasks are testing the data received from the UART network. So on the left, I have the CPU that sends the data. On the right, I have tasks that test the data processed by the UART network. So let's focus on the transmitter part. So we have dummy TX. Dummy TX is here. So dummy TX, it's a very simple task. We define a stimulus and we write the content of the stimulus into the data to send port of your network. So it's really acting like a CPU. It just sends data to this UART network IP core via the UART network data to send bus. So we have the dummy TX. The dummy TX is a very simple task. So we have a stimulus and we send the content of the stimulus to the UART network. Okay, so it's really acting like a CPU that sends data to UART network. And the UART network processes this data and send it to the TX port to expected. So again, dummy TX send data to UART network receive the data from dummy TX, process this data and send it to the TX port. Okay. And if we have a look on expected, here is expected. We receive the data from UART network, we read the data from the port TX and we verify if it's okay and we print the result. So the first thing it's doing is waiting for a falling edge. Why? Because if we have a look on a data frame, a typical data frame, there is a start bit, 5 to 9 data bits, usually it's 8, a parity bit and a stop bit. And the start bit is held at high voltage when it's not transmitting data. And the transmission line goes from high to low for one clock cycle when it starts transmitting data. So in the expected loop, that's what we are waiting. We wait for the falling edge, which means it's a start bit. And then we read the content of the frame and we display the content. So let's try that. How to simulate that, how to execute the code. So we go to your test, right click, run as, run configuration. So we make a new simulation. We select the project, so it's yours. We select an entity, so it's com.synflow.urts.urts.test. com.synflow.urts.test, com.synflow.urts.test, apply and run. So the simulation is started. We can stop it by clicking on terminate. Let's have a look on what's happening. So the stimulus here, dummy TX stands the stimulus. So the stimulus is 61, 62, 63, 80, etc. This is the stimulus n, and we look on expected what's actually happening. So we print the result, so received, and we received 61, 62, 63, 80, as we expect. So our UART network is working well, and as we expect. So that's how you simulate an application, an IP core, using the Synflow SDK. So the simulation, the Synflow simulator, is cycle accurate and bit accurate. So we'll have the same result using the Synflow simulator and using model sim, for example, on the generated Verilog. And we can verify that right now by clicking on Run Configuration. So instead of using the Synflow simulator, I can use directly model sim. So I will not compile and run the CX code, I will compile and run the generated Verilog. So what's happening when I would click on Run? The Synflow SDK will compile the CX code, generate the Verilog, and then it will run model sim using that generated Verilog. So let's try that. Run. The Synflow SDK starts model sim. It setups model sim so that model sim use the generated Verilog. It creates automatically the waveform view that you can see here, and it runs model sim for defined amount of time. So you can run for longer. Okay. So I have run the simulation for a longer period of time, and I can see that I have the same result using model sim on the generated Verilog that I had using the Synflow simulator on the CX code. So I'm receiving 61, 62, 63, 80, 0, and so on. So that's exactly what we were expecting, and that's how you simulate using model sim the generated Verilog. And of course you can have a look on what's happening inside the network. So the network is here, UART network, and there are the tasks. If we go to UART TX, for example, you can see the prescaler, the TX task, you can see that the TX tags receive 62, 63, 80. So those are the data received from the source, from the dummy, which is acting like a CPU. And the TX tags convert the 62 into bits, so start bits and data bit, and send those data on the TX port, that port here. Okay, so that's how you simulate your design. That's how you simulate your code, your application, your IP cores. It's very easy, as you can see, very simple. You just click, run, and the Synflow SDK does the job for you. Now, the next step is to make a synthesis, of course. It's to use an FPGA and to test your application on an FPGA. To do a synthesis, it's very easy. So, again, I will make a synthesis on the UART network. So say that I want to test my UART on the network. I will make a run configuration, same process, but synthesis. So I create a new configuration file. My project is UART. Then my entity is com.synflow.uart network. Apply. No, first I need a new configuration file. I select a vendor. For me it will be Lattice today. I select a board. It will be other. Apply and run. So what's happening now? You can see that things are happening. So the Synflow SDK has automatically generated a project for Lattice. It has automatically added all the source file, all the Verilog source files to this project, and then it starts a synthesis. So what you can see right now on the console is a synthesis being performed by the Lattice synthesizer. And after the synthesis, it will create a bitmap. That's what you can see here. It's creating a bitmap. So the bitmap is the file that you use to program your FPGA. So bitstream is here. And it will try to program the FPGA, but that won't work because my FPGA is not connected to my computer right now. So what has happened? The Synflow SDK has created a project for this Lattice. It has executed the Lattice compiler and synthesizer. The Lattice compiler has created the bitmap, which is this file, and I can now use that bitmap to program my FPGA. But first, usually you want to assign the pins, and you want to add a FIFO or to set up your FPGA. So to do so, you can just click on Project, open the generated project. And you can see in the generated project that you already have everything configured. So to modify the mapping, for example, in my case, clock reset on L5 A21, so that's correct. But I also need to add the TX and RX port. So I will modify that file to add a TX-RX and add a site. I can also modify the FPGA if I want, the device, or modify the strategy, and so on. So that's the next step. It's configuring the synthesis with and adding the necessary options, necessary mapping. To do so, you need to read the documentation of your board provider or your FPGA to know the mapping of your own FPGA. We provide some pre-configured board and model. As you can see, we have some board from Xilinx, from Altera, and for Lattice. If you want us to add your board, just contact us. And once added, you will have everything automatically configured with the clock, reset and other pin if you have other pins. Within the synthesizer, you can then click on netlist view. You can see the ports input. So I think you remember resetn, RX, data reward ready, data to send valid, etc. So that's how you make a synthesis. Again, very easy, just click run configuration, configure your synthesis, and let the tool make the job for you. Okay, so I hope you liked that video. I have shown you how to test your application, how to simulate your application, and how to make a synthesis. If you have any question, feel free to send us an email and we will answer you. If you have feedback also, feel free to send us an email. I wish you a good day.